All right, in the last video, you made a bracket or some other holding device that holds this motor onto your box. This video will be to discuss how you will make gears to have the motor drive the shaft, but also have a gear reduction or a gear ratio of somewhere between 2.5 and 3.5. If you choose to use pulleys, there is yet another video for that. So you choose whether you're doing pulleys or gears. This video will be about how to do gears. The advantage of gears is that, first of all, they look kind of cool. Second of all, that they're a little stronger. The disadvantage is that they have to be a little more precise. All right, so let's get going with making some gears. So first, you have to start uh, a new design. Well, first of all, we need to know what the distance is between this shaft and that shaft. So wherever your motor is going to be, you need to know what that distance is. So one of the things that we can do is we can put an axis uh, through this cylinder and another one through that cylinder. Whoops, I guess I have to do one at a time. Let's make an axis through this cylinder. And wherever your motor is going to end up being, we need to know the distance between that guy and that guy. Okay, so that's going to be important later on when we know that our two diameters need to add up to whatever this is. All right, so that's important to know that number. Next, we're going to start a new design. And there's a new thing we haven't used yet in utilities. So in these tabs up here, go to utilities and go to add-ins, scripts and add-ins. And down here at the very bottom, the second that has the yellow and blue icon that stands for Python language, we're going to run that. And that brings up this window that's got a bunch of stuff on it. Now, right now, the pitch diameter, which is this circle where the teeth hit each other, so it's a little less than the hole diameter, but it's the most important thing because it's really where the outside diameter of what hits is 12. Obviously, that's a little too big. So the important things that we need to deal with is this diametrical pitch. Okay, that's going to tell us how many teeth per inch there are. Okay, and the number of teeth. So the diametrical pitch is going to need to be the same for both of those gears. So as we go up, let's go to 8 here. Notice that the pitch diameter dropped, okay? We can also change the number of teeth. Let's lower the number of teeth and see what happens, and notice that that kind of goes up a little bit. So you need to kind of focus on, don't do too many teeth or the laser will burn them off. If I did 80 teeth, it's going to become, first of all, bigger, which is a problem, but probably somewhere between 12 and 24 teeth, or 12 and 30 teeth is what we're going to want. Actually, I take that back because we have to be 3.5. Somewhere between 12 and 40 is about right. So let's start off with a gear where I have, let's say, 36 teeth. Okay, that's 4.5 inches. That's a little bit too big. So maybe I need a couple more. Maybe I need to go a couple more teeth. Now, it's also going to give you problems that says, oh, your root fillet radius, this thing is now too big. So you can make that smaller. Let's make it 0.03. Okay. So, and you just have to play around with this until you get a gear that works in the size that works for you. Now, one important thing is you have to make this hole diameter 0 because we don't want a hole. We're going to steal one of these hole templates for that to make that hole. Whoops. I forgot, by the way, until you click OK, your gear is going to go away until you save it. So make sure you have everything. When I clicked out of this tab, that's why that went away. Now, once you think you've got this right and it's what you want it to be, take a little screenshot of that with your snipping tool so that you know what that is, because you're going to need to compare these numbers to your other numbers. So I've got that saved. Click OK, because you're not going to be able to get that back. And there's that gear. If it didn't work out, try it again. If it doesn't look right, you can always play around with it because it's pretty easy to do. All right, now we need to make it. This is my bigger gear because it's 3 inches, which is pretty big. We're going to need to make the other gear that's smaller. Now, what's important here is we're going to go back to scripts and add-ins. We're going to go to spur gear. We're going to run. Okay, is that diametral pitch needs to be the same as the previous one. So it's my previous one was 12. I need to keep it that way. And now I'm going to just take the number of teeth and change it and click OK. That pitch needs to stay the same because I need the teeth to match up. And if I don't do that, the teeth won't match up. All right, so I clicked OK. There's that gear in there, which I can now highlight and move. Okay, and if you make them together and then rotate it a little bit, you should be able to see when we look at that those teeth are going to mesh together. Okay, and we do want that as its own entity. That's going to be important. All right, cool. So we've got our 2 gears that mesh together. Now, here's what's important is we need to go back and look, and we might need to try this again because these 2 diameters need to add up to, remember, the distance between this axis and this axis. Now, if your motor can slide up and down a little bit to adjust that distance, that's fine, but you can't have it way different than this distance is unless you change your bracket to hold it farther away or whatever. So that's part of the engineering of this assignment. All right, now that we've got these 2, no holes in them, we're going to place the hole templates. So this one will go on the big gear, okay? And if you're going to cut out wood, which we're doing most of the time, we're doing this one for the little gear. So here's the easiest way to do that is to highlight it, hit copy, okay? We're going to go back to our, we're going to sketch. Oops, go back to solid, sketch. I'm going to sketch on this surface. I was hit reverse position, okay? Oh, I should have saved that position from earlier. Hold on, let's undo that. Okay, okay, so I do need to save that position. They'll move. Let's try that again. Save here. I want to capture the position this time. All right, so notice that we do have an origin here. Over here, we'll be able to copy the center point, and we're going to right-click, paste. Now, when this happens, it already is putting that on the origin, but I'm going to, just to make sure, I'm going to move this thing over a little bit, and then I'm going to choose this point-to-point option that's over here and choose the 2 points I want to put together, which are this point and that point, to make sure I'm right in the center. Okay, click OK. Now we can cut that out. Same thing with this one. We're going to do another sketch. Back to solid. Oops, I'm in the sketch tab. I should have hit finish sketch. We're going to sketch over here. Probably could have done it in the same one, but because they're 2 bodies, I want to make sure we're same. Whoops, I forgot that I need to get that sketch. So let's go back to hole templates. Now we're going to highlight that one, copy, and in here, we're going to paste. It's probably going to put it over here at the origin. Okay, a little over, so we'll scoot that. And then again, we're going to choose that point to point, and we're going to put this point to that point. Okay. Okay, now we've got our things that we can cut. And we've got our one that's going to go on the spindle of the box and one that's going to go on the spindle of the motor. We can turn off our sketches. Now we're going to prepare these for, why didn't my sketches turn off? I guess these diameters stay there on the gears. So our next step is to prepare these for laser cutting. So first of all, move them far enough apart so that you're not going to have the laser interfere when it cuts. Not way out here, but just enough so that it's not going to accidentally burn through more than one thing. And we're going to go ahead and create the sketch that we're going to use for the actual cutting. So we'll sketch on that surface. Okay, hit capture position again because we want it to be these two where they are. And we're going to P for project. We're going to project the geometry of that dude and click OK. Make sure that it's got purple lines all around. Sometimes you have to do it twice. Project again. We're going to project that guy. Okay, now we've got all of that cut out, and now we can do our sketch 3. I don't know if we can just save it as a PDF. I think because these are all curves or lines. I don't know. I'll tell you in class whether we can do save as DXF or you have to create splines as polylines. I'd prefer to do this as save as DXF. I'll tell you which one we do, and then we can cut that on the laser cutter. All right, and hopefully your gears will work. If not, you'll have to come back to this video and play around with the sizes until you get it right. All right, hope it worked out for you. We'll see your automata automated.